30 seconds to read the question, thinking about what information they're giving you that you might need to use at some point, and thinking about what do I actually need to do here? Do I need to differentiate, integrate, solve something, sub something in? Now hopefully you noticed at the very beginning a particle of mass 500. As soon as you see the mass, then write down F equals ma, because we're going to be using F equals ma definitely, and we're going to be subbing in that mass that they told us, which was 400 grams. But we can't sub grams into F equals ma, we need to sub in kilograms. So that is a classic trick. ICU examiner. I'll put together a bunch of ICU examiners so that you can see how common this little trick is. So you're going to sub in the mass, but in kilograms, not in grams, for sure. For sure that's going to happen. Okay, next. Is initially at rest at, right, this is information. I'm going to write this information down. Initially at rest, and it's initially at the origin. Initially at the origin, no displacement. Okay, they tell me V, which I've got written in the bottom left, and now we're on to the question. Find an expression for the force. Well, there you go, that's what we were already doing. I can just put a part A on it now. We knew we were going to use that, we were definitely going to use that. So even if you just wrote it down and subbed in the mass in kilograms, you're going to get some marks for that. So what do we need to do? We've got F equals, we know the mass in kilograms, and you need the acceleration. How do we get the acceleration? We differentiate the velocity. Okay, you can do that one now. Part B, find the time when the particle, find the time. So we're going to be solving either V equals 0 or S equals 0. No, not equals 0. We're going to be solving either V equals something to find the time, or solving S equals something to find the time, or solving A equals something to find the time. And there might be a question inside a question, so let's see. Find the time when the particle passes through the origin. Okay, passing through the origin is when S is 0, so there's no question in question here. We're going, well, not obviously, we're going to have to get S and put it equal to 0. How do we get S? We need to integrate V. Okay, now when you integrate V, which I'm sure you can do, I'll put the steps here to remind you. So we're going to do the integral of V, and then you do that by increasing the powers and dividing by the new powers, and then maybe tidy it up a little bit. And now what we've got is S, and you mustn't forget on the end of that S there is a plus C. Now we can't solve S is 0, which is what we actually want to do, until we find out what C is. So we need some information, and this is the information that we need. When T is 0, S is 0. So if you sub that piece of information in here, then you will get C, and then you know the whole of S, and then what you're going to do is you're going to put this S equal to 0, and you're going to solve it to find T, and then you're all done. Oh, I'm sorry, let me move that so you can actually see. There. Okay, I'm going to give you pause time now, 15 seconds to get yourself to the pause button, and then I'll put up the answers and we can talk about what you actually had to do there. Just give you a bit of time to look at it yourself. So what do we have to do here? Part A wasn't actually a variable accelerator. Well, no, it was, because we had to differentiate V to get A to sub it into F equals ma. For part B, we had to integrate V to get S, and then we had to find the value of the plus C. So in terms of ticking off what they're asking us to do, we didn't have to find the distance. There was no confusion about speed or deceleration or anything like that. It didn't mention instantaneously at rest or changes direction, which is where V is 0. We didn't have one of our questions inside a question, but we did have to use information given to find the value of an unknown, which was plus C. So when it comes right down to it, let's move the question out of the way now. What did we actually have to do? We had to find the times when S was naught.